Welcome to Lessons with Mr. Clark. Today we're going to work on displaying data. We're going to do 8 practice problems. All right, let's dive in. Question 1. A definition of a statistical question is given below. A statistical question is any question whose answer could involve working with more than one data value. You can't work with just one data value. Got to be multiple. That way we can display our data. So a statistical question. Mr. King asked his students, how many words did you type yesterday? So he asked a bunch of students. Everyone gave responses, so yeah, it's statistical. Anne asked one of the girls on her team. Doesn't matter, she only asked one person. That's not statistical. You need lots of stats. Part C, Mrs. Bryan asked one of her students. She only asked one person. Nope, not statistical. D, Donna asked 70 students at her school, what is the distance in miles from your house to school? Yeah, definitely statistical. Lastly, Aldo asked one of his classmates. He only asked one person. Come on, Aldo, ask a lot of people. All right, question 2. Yolanda wants to find the average height of students in the 10th grade at Lincoln High School, so she will use the heights of 50 students in the 10th grade to find the average height. Okay. So which unit could be used for the unit of measurement? A unit of measurement to measure height. Feet works, not pounds. That's not for height. Ounces doesn't work. Centimeters works. It's not great, but it works. Kilograms don't work. We're checking everything that applies. Kilograms would be weight. Perpy. Which of the procedures below would be the best way to find the average height? Okay, we want to find the average height. So we want it to be as random as we can with 10th graders. And we want to ask as many people as we can. Okay, so the first one says randomly pick 50 students from the 10th grade and have them state their own heights. Yeah, that's okay. I don't really love them stating their own heights. Next one, randomly pick 50 students from 10th grade and measure their heights. Ooh, I like that one so far. Measure the height of 50 volunteers. We don't want to just get volunteers. We want it to be more random than that. Ask for 50 volunteers. Yeah, we don't want it to be that. So the best answer, randomly pick 50, measure their heights. Question 3. In a poll, 32 residents were asked how many pets they had in their house. The line plot shows how the residents answered. Okay, so most of them didn't have any. A couple of people had 5 pets. 3 people did. Wow. All right, part A. Rate the ratio of number of residents who have 5 pets. So we read left to right, we write left to right. The people with 5 pets, there's 3 of them. To the number of residents who have 3 pets. 1, 2, 3, 4 of them. So 3 to 4. We can't simplify that. Part B, write the ratio of number of residents who have 4 pets. 1, 2, 3, 4, 5, 6 people. To the total number of residents in the poll. Well, I could count all the X's, but it tells me right up top there's 32. So 6 to 32 works. We could simplify them. Divide them both by 2. 3 to 16, same ratio. Either of those should work. Question 4. TechWiz Company Entertainment sells 4 types of products. They sell radios, video games, DVDs, and CDs. The numbers sold for 2019 and 2020 are shown in the double bar graph. Use the graph to answer your question. So 2019's in blue, 2020's in stripes. Looks like 2019 they did better in most things, besides radios. Estimate the number of video games sold in 2019. Okay, so just video games 2019, just the blue. Right there, it's between 800 and 900. It looks like it's a little more than halfway. So how about we do 820 or so? Not quite 850. 950. Yeah, it's probably closer to 950 if I really zoom in. So 900 would be halfway, so 950 is a good estimate for that. Okay, next. Which product sold more in 2019? 950 video games, VG, I'm going to call it. Which product sold more in 2019 than 2020? Well, video games did, DVDs and CDs did. All of them except for radios. Which product sold the most over 2 years? Oh, interesting. Okay, so we're looking for the two highest when we combine them. If I put that on top of that, we put that on top of that, we can stack them. It looks like DVDs. They're top seller. Okay, question 5. The executives of Hydrate, a soda and energy drink company, conducted a quarterly review of the company's production facilities. For the review, the number of workers' stoppages due to mechanical failure were counted at each of the company's bottling plants. The histogram below summarizes the data. Use the histogram to answer each of the questions. Okay, so the number of work stoppages. Okay, you can kind of see the ranges of each. How many bottling plants had from 11 to 17 work stoppages? So how many plants are in this category? There's 6 of them. How many bottling plants had 18 or more work stoppages? So it's those 4, and those 8, and those 7. So 19 bottling plants. That's a big company, a lot of bottling plants. What is the class width? Okay, so the class width. To get the class width, we look at how wide each category is. So from 32 to 38, or 25 to 31, or 18 to 24, or 11 to 17, or 4 to 10. Okay, this is interesting. You could do one number minus the other, but then you have to add 1 to it. So the answer is really 7 for each of these. Because think about the numbers 4 to 10. You have 4, 5, 6, 7, 8, 9, and 10. Same with 11 to 17. So the width of each is 7. All right, question 6. Stem and leaf plots. Nice. Stem and leaf plot below gives the test scores for 18 students in Mrs. Yang's history class. Use the plot to answer the question below. So one student scored a 58, so that'd be an F. 2 students scored in the 90s, 94 and 97. Those are A's. Most people had C's, a couple, 4 B's, 3 D's. Okay, and the key tells you 5-8 means 50. So what was the highest score in the 60s? So if we go to the 60s here, we had a 66, we had a 67 and a 68. Why is the 68? Lowest score overall was a 58. Only one person failed. How many students scored in the 80s? Well, 1, 2, 3, 4 students did. Okay, that's reading that stem and leaf. All right, now box and whiskers. I like these things. All right, so we're going to find yesterday's high temperature in Fahrenheit in 17 U.S. cities. So the highest was an 85. That's going to be my top. The lowest is a 55. It's going to be my bottom. So those are my whiskers. Let's find the median. So with the median, we're finding the middle number. They're already in order for us. That's good. Since there's 17 cities, we're going to have an odd number. That means it leaves us with 1 in the middle. So we're going to work our way into the middle of the data. I like working from the outside in. It's going to actually be the 8th number on our list. 70. So there should be 8 numbers below. I'm sorry, 72. 8 numbers below and 8 numbers above. Okay, so 72. 8 numbers below, 8 numbers above. 72. It's going to be my median. Okay, now we need to find our first quartile. So since there was 1 number in the middle, we cross it out. Of the 8 numbers below, now we have 2 middle numbers. Between the... Oh, I drew that wrong. Between 59 and 62. So we could add it up and divide by 2. So that will give you 60.5. So 60.5 is my my first quartile, my lower quartile. And the same on the other side. Work my way to the middle. Should have two numbers in the middle. Now 80 and 80. Well, that's easy. Just 80. Okay, so down here I got my first quartile, my median, my upper quartile or third quartile, and then my whiskers. So 50% of the class fits in the middle, 25 below, 25 above. So it's really like that if I was actually to be able to draw the thing there. Okay, that's your box and whiskers. Okay, so now let's look at interpreting this. Two athletes are training for a cycling race. Each athlete recorded the distance in miles of their previous 95 training rides. It's a lot of training rides. The box and whisker plot below, sometimes called box plots, summarize the distance recorded for each athlete. Use that to answer the questions. Which athlete went on the shortest training ride? So we have athlete A and athlete B. To look at their one shortest ride, we look all the way to the left. Athlete A had the shortest one. Which athlete had a distance with a larger interquartile range? So we're looking at the range. We're looking at the box in the middle, the IQR. Which has the biggest inner box? Well, it's kind of obvious. Athlete A has the bigger one. Not which was higher, but which has the bigger box. Question 3. Which athlete had a smaller range of distances? So we're looking at the two endpoints. Which one has the smaller range, meaning the numbers are closer to together, biggest minus smallest? Well, that's athlete B. Which athlete had a greater median distance? So for the median, all we're doing is looking for the middle, whichever one's in the middle. So you can see those two. Athlete B's median, he usually did 27 miles. Athlete A normally did about 29 miles. So athlete A is bigger. Okay, that's interpreting the box and whisker plot.